minute, sir. 1 minute. ಶುರು ಮಾಡಿದೆ ಸರ್.
Yes, sir. Thank you, sir. Thank you, sir.
ಸೊ ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರಗಳು. ಇಂದಿನ ಉಪನ್ಯಾಸ ಕಾರ್ಯಕ್ರಮದಲ್ಲಿ ಶ್ರೀ ಸಂದೀಪ್ ಶಾಸ್ತ್ರಾಳ್ ಸರ್ ಅವರು ಲೆನ್ಸ್ ಲಾ ಎಂಬ ವಿಷಯದ ಮೇಲೆ ಉಪನ್ಯಾಸ ನಡೆಯಲಿದ್ದು, ಈ ಒಂದು ವಿಜ್ಞಾನ ಪ್ರತಿಭಾ ಶೋಧ ಯೋಜನಾ ಉಪನ್ಯಾಸ ಕಾರ್ಯಕ್ರಮಕ್ಕೆ ಅವರನ್ನು ಈ ವೇದಿಕೆಗೆ ಸ್ವಾಗತಿಸುತ್ತಿದ್ದೇನೆ. ವೆಲ್ಕಮ್ ಟು ಸರ್.
Thank you, sir. Thank you, sir. Yes, sir.
ಸೊ ಅದೇ ರೀತಿ ನಮ್ಮ ಅಕಾಡೆಮಿಯ ಅಧ್ಯಕ್ಷರಾದಂತಹ ಪ್ರೊಫೆಸರ್ ಅಯ್ಯಪ್ಪನ್ ಸರ್ ಅವರನ್ನು ಕೂಡ ಸ್ವಾಗತಿಸುತ್ತಾ, ಹಾಗೂ ಈ ಒಂದು ಕಾರ್ಯಕ್ರಮವನ್ನು ಆಯೋಜನೆಗೊಳಿಸಿ ನಮಗೆ ಪ್ರತಿನಿತ್ಯವೂ ಸಲಹೆ ಸೂಚನೆಗಳು ನೀಡುತ್ತಾ ಬಂದಿರೋ ನಮ್ಮ ಅಕಾಡೆಮಿಯ ಮುಖ್ಯ ಕಾರ್ಯನಿರ್ವಾಹಕ ಅಧಿಕಾರಿಗಳಾದಂತಹ ಡಾಕ್ಟರ್ ರಮೇಶ್ ಸರ್ಗೂ ಕೂಡ ವೆಲ್ಕಮ್ ಟು ಸರ್. ಹಾಗೂ ಇಂದು ಹಾಜರಾಗಿರುವ ನನ್ನ ಎಲ್ಲ ವಿದ್ಯಾರ್ಥಿ ಮಿತ್ರರು, ಸಹೋದ್ಯೋಗಿಗಳು ಹಾಗೂ ವೆಬೆಕ್ಸ್ ವೃಂದದವರು, ಅಧ್ಯಾಪಕರು, ಅಧ್ಯಾಪಕರೇತರ ವೃಂದದವರಿಗೂ ಕೂಡ ಸ್ವಾಗತವನ್ನು ಬಯಸುತ್ತಾ, ಸೊ ಈಗ ನಮ್ಮ ಸಂದೀಪ್ ಸರ್ ಅವರು ಈ ಒಂದು ಉಪನ್ಯಾಸ ಕಾರ್ಯಕ್ರಮದಲ್ಲಿ ನಮ್ಮ ವಿಜ್ಞಾನ ಪ್ರತಿಭಾ ಶೋಧನಾ ಯೋಜನೆ ಉಪನ್ಯಾಸ ಕಾರ್ಯಕ್ರಮದಲ್ಲಿ ಅಕಾಡೆಮಿಗೆ ಹಲವಾರು ತರಗತಿಗಳನ್ನ ನಡೆಸಿಕೊಟ್ಟಿದ್ದು, ಅವರ ಬಗ್ಗೆ ನಾವು ಆಲ್ರೆಡಿ ಒಂದು ಕಿರುಪರಿಚಯನ್ನು ಕೂಡ ಮಾಡಿಕೊಟ್ಟಿದ್ದಂತ ಸಂದರ್ಭದಲ್ಲಿ ಜೊತೆಗೆ ಸಮಯಾವಕಾಶವು ಕಡಿಮೆ ಇರುವ ಕಾರಣ ಸೊ ನೇರವಾಗಿ ಈ ವೇದಿಕೆಯನ್ನು ಅವರಿಗೋಸ್ಕರ ಹಂಚಿಕೊಳ್ಳಲು ಬಿಡುತ್ತಿದ್ದೆ. ಓವರ್ ಟು ಯು ಸರ್.
Thank you, sir. Thank you so much. Yes. Good afternoon, students. Today we'll take up a small topic that's concept of Lenz law. Down the line, if you observe, okay, ನಮಗೂ ಇಡೀ ಪ್ರಪಂಚದಲ್ಲಿ ಏನಪ್ಪ ವಾಟ್ ಈಸ್ ದ ಮೋಸ್ಟ್ ಇಂಪಾರ್ಟೆಂಟ್ ಆರ್ ವೈಟಲ್ ಥಿಂಗ್ ಅಂತ ನಾನು ಕೇಳಿದ್ರೆ, ಸೊ ಇಂಟರ್ನೆಟ್ ಮತ್ತೆ ಪವರ್. Without electricity, almost that we cannot survive our life. Okay, what is that so-called mechanical life or luxurious life? That's how it is going. But in all these cases, how we are going to produce electricity, that is from the concept of AC generator anta. AC generator, how it will work, that's based on the concept of electromagnetic induction. So before we learn from the concept of electromagnetic induction, first we need to learn about the magnetic flux. So magnetic flux is a term. How it is going to be determined? Imagine that if you have a bar magnet here, this is the North Pole and as well as the South Pole. So from this particular portion, a few of the magnetic lines of force will be already emanating. So how the structure will be, they will be there starting from the North Pole into the South Pole and again south to north inside a bar magnet. So outside the bar magnet, it is from the north to the south. So these are all the various field lines, how it will be presented. Now, imagine now if I take any particular cross-sectional area. Imagine this is going to be the dotted line. I have a particular cross-sectional area. What is the amount of magnetic flux I have taken it? So people says that it is nothing but the flux density. How many number of field lines are actually crossing per unit area in normal direction? That's the concept of magnetic flux, how we'll be defining. But in terms of mathematically, so we will be defining as the dot product between magnetic field and as well as the area. This is for one turn. If I have the n number of turns of a coil, okay, so then it will become n into b into a. So if I take a dot product between them, so ba into cos theta. What is the theta here? That's important. That's angle between the magnetic field and as well as the area vector. Not angle between B and plane. It is actually angle between the B and as well as the area vector. That's how I will be defining the magnetic flux. So flux is equal to n into B into A into cos theta. So the people have found that, okay, especially the two people we need to speak about. One is nothing but Henry and one more is nothing but the Michael Faraday. What they found, they made actually reverse experiment. Okay, Oersted, what he has observed, there is a constant current carrying conductor. From this, surrounded by you have a magnetic field will be present. Now, they made it exactly the reverse statement. From the magnetic field, can I able to get the electric field or not? That is the idea. Okay, from the magnetic field, can I able to get an electric field or not? So what is the conclusion drawn by either Henry or Michael Faraday? Both of them has worked independently. Of course, Faraday has given for the first, and maybe after a year Henry has given. So I'm not going in detail what experiments they have done, because today's topic is about the Lenz law. I'm just giving only introduction to that before this Lenz law. So what is the conclusion has drawn by these two great scientists? Now, unless and until if you have change in magnetic field, especially change in the flux, then only that is going to be creating an electric field. A constant magnetic field or a constant magnetic flux will never produce any electric field. The change in the magnetic flux only will produce the electric field. So that is the idea what they have developed. So this is the definition of electromagnetic induction. Whenever there is a change in the magnetic flux linked with a closed loop, then induced EMF will be produced. So all his observations from the Michael Faraday, he has developed the two observations. They are named according to his observations. That is Faraday's first law and as well as the Faraday's second law. What is the Faraday's first law? That itself is electromagnetic induction, the definition. So as long as there is a change in the magnetic flux linked with a closed coil, induced EMF will be produced. Now, if I look with the second Faraday's law, what he says, the induced EMF produced is directly proportional to the rate of change of magnetic flux. How quickly you change the magnetic flux with respect to the time, and that much quickly I can able to produce the induced EMF. That is very important. How quickly you are changing the magnetic flux, then only I can able to produce the induced EMF. So if I look at about the magnitude wise, proportionality constant, I'm going to take the number of turns. So N into d by dt of magnetic flux. That is a criteria. Now the hero of the presentation will come into the picture. He says the induced EMF produced E is equal to minus N into d phi by dt. So what is this particular so-called negative sign is given? This is the concept of what exactly Lenz law. So this is up to the story of your Faraday's second law. The negative sign has always an important meaning in a physics. You need to understand. So that is a negative sign is given here by the concept of the Lenz law. So what is this negative sign? How it will be working? That is what we need to understand. Now, generally when the negative sign comes in terms of a vectors, that says both vectors pointing in opposite in the direction. But if the same negative sign is giving in terms of a scalars, especially in terms of the change, the values. Here you have the, if you observe here, maybe if it is instantaneous values, it will come. Now, if I ask for the average induced EMF, so I can write N into delta phi divided by delta t with a negative sign. So what it is going to signify? Now, with respect to the change in the time, you are going to get the change in the flux, right? So what is that meaning of this particular negative sign? That is what we need to observe. So now let's take the concept of Lenz law. So which is very important, even 3 marks question for you, the concept of Lenz law, or for 2 marks, or for 1 mark, even they may ask you to derive, is to state that Lenz law here. And for competitive exams also, a few questions can be given. So that is what we will be discussing. So most will be giving emphasis on, okay, the conceptual questions, okay, both in board and as well as the competitive exams related to this topic. So the Lenz law says the direction of induced current, the direction of induced current is such that to oppose the cause. So the important point is here, the so-called oppose. How it has to oppose? By giving a direction of the induced current. That means you cannot have any direction of the current whatever the way you like. There is one particular direction of the, because whenever you take a loop, that means it's a closed loop. Either it will be in clockwise or anti-clockwise or whatever. But the direction is going to be determined by the Lenz. How much current you are getting, that is going to be given by your Faraday's law. But what direction current is coming, that is going to be given by the Lenz law. So it is opposed to the cause. Now the question comes, sir, what is that so-called cause which we are taking? We have discussed just now. What is the cause of producing the so-called your electromagnetic induction? That is nothing but the change of the flux. Who is the cause here? The change of flux. Sir, then how to oppose the change of the flux? Very simple. If the flux is decreasing, what will happen? If the flux is increasing, what will happen? That is only the criteria. So now if I write the cause, only two possibilities I have. So the flux is increasing with time. The flux is increasing with time, or flux is decreasing with time. Decreasing with time. Now I need to understand what is that so-called effects, how it will be working. Simple. The first effect, if I observe for the first cause, what is the effect? What did I tell? It has to oppose the cause. What is the cause here? Flux is increasing. Now opposition means what? The flux has to decrease. Sir, how the flux will change? So flux is nothing but what I say, B into A into cos theta. Now area remains constant, theta remains constant. So by changing the magnetic field, then flux also can be changed. Now what is your logic? Here the cause is so-called increasing. Now the effect has to decrease. To decrease means what does it mean? Magnetic field is a vector quantity. So to decrease means what does it mean? Effective magnetic field has to decrease. Effective magnetic field has to decrease means what does that mean? You need to think now. There will be two magnetic fields. They have to increase means both of them should be in the same direction. They have to decrease means both of them should be in the opposite direction. That's only the simple logic. So now what I can say here, say it is increasing. The cause is increasing means the effect has to decrease. Now I can say the effect has to decrease. To decrease means what does it mean? The induced magnetic field due to the induced current and existing magnetic field, both of them should be in opposite direction. That is very, very important. Okay. Why? Because magnetic field is a vector. Magnetic field is a vector means what does it mean? If they're in opposite direction, then only they can be subtracted. If they're in the same direction, then they can be added. So here clearly says I have to decrease. Then I can write the existing and as well as the induced magnetic field are opposite in the direction. That is the idea. Now let me take here the flux is decreasing. Now, who is the cause here? Decreasing. Now, I have to increase. I have to increase. Sir, when you can increase? Simple. To increase means what does it mean? I have to add both the vectors. That's only the criteria. So, to add both the vectors, what does it mean? They have to be in what exactly? Same direction. Now, existing and as well as the induced are in same direction. That is a criteria. Once you know this particular concept, then we can able to do anything related to your the concept of Lenz law. Very simple. Do you remember what is the cause and effect? So the Lenz law negative sign says, what does it mean? It has to oppose the change of flux. If it is increasing, it has to decrease. How to decrease? The two magnetic fields has to be in opposite direction. If it is decreasing, then it has to increase. How to increase? Both magnetic fields should be in the same direction. That is the concept of Lenz law. Now you might be thinking a question, what is the guarantee that so-called your Lenz law is really right or not? The gentleman says something, why I have to believe? ನಿಮ್ಗೆ ಆ ಡೌಟ್ ಬರ್ಬೋದು. ಆ ಥರ ಅಂದ್ರೆ ಏನ್ ಮಾಡ್ಬೇಕು? ಸಿಂಪಲ್. ನಂಗೆ ಗೊತ್ತಿರೋ ಲಾಸ್ಟ್ ಒಂದು ತಗೊಳ್ಳೋಣ, ಈ ಲೆನ್ಸ್ ಲಾಕ್ ಅಪ್ಲೈ ಮಾಡೋಣ, ಅದು ಸ್ಯಾಟಿಸ್ಫೈ ಆಯ್ತು ಅಂದ್ರೆ ಏನಂತ ಅರ್ಥ? ಆವಾಗ ಲೆನ್ಸ್ ಲಾನು ಕರೆಕ್ಟೇ ಅಂತ. ಇಲ್ಲ ನಮ್ಗೆ ಗೊತ್ತಿರೋದು ಆಲ್ರೆಡಿ ಕರೆಕ್ಟು ಅಂತ ನಂಗೆ ಒಂದು ವಿಷಯ ಗೊತ್ತು, ಇನ್ ಕೇಸ್ ಅದು ಫೇಲ್ ಆಯ್ತು ಅಂದ್ರೆ ಏನಂತ ಅರ್ಥ? ನಿಮ್ ಲೆನ್ಸ್ ಲಾನು ಫೇಲು ಅಂತ ಅರ್ಥ. ಸೊ ಈಗ ವಾಟ್ ಈಸ್ ದ ನೋನ್ ಥಿಂಗ್ ಟು ಮೀ? ಸಮ್ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ರಿಸಲ್ಟ್ಸ್. ವಾಟ್ ಈಸ್ ದಟ್ ನೋನ್ ಟು ಮೀ? ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ಲಾ ಆಫ್ ಕನ್ಸರ್ವೇಷನ್ ಆಫ್ ಎನರ್ಜಿ. ಈಗ ಈ ಲಾ ಆಫ್ ಕನ್ಸರ್ವೇಷನ್ ಆಫ್ ಎನರ್ಜಿ ಲೆನ್ಸ್ ಲಾಕ್ ಅಪ್ಲೈ ಮಾಡೋಣ. In case if it is satisfied, then I can think even Lenz law is right. If it is fails, then Lenz law is also wrong. ಅಷ್ಟೇ, ಇನ್ನೇನಿಲ್ಲ. ಏನಯ್ಯ law of conservation of energy? Simple. Energy can neither be created nor be destroyed. Okay, it can always convert from one form of energy to another form. Total energy always remains constant. Correct? ಈಗ ಅದೇ ವಿಷಯ ಚೆಕ್ ಮಾಡೋಣ. What is that so called your law of conservation of energy? How it will be deal with your concept of Lenz law? Yes. Now, let me take a small coil here. There is a coil like this. I have two cases. This is case number 1. This is case number 2. ಏನಯ ಆ 2 cases ಈಗ ನೋಡೋಣ. Imagine now there is a bar magnet with a north pole and as well as a south pole like this. There is a north pole and as well as a south pole like this. I'm taking the bar magnet along the axis of a coil. Imagine that this so-called bar magnet is approaching the coil. Here also it is approaching the coil only. But then why there is a change in the case number 1 and case number 2? You might be thinking. Simple. One simple concept ಏನಂದ್ರೆ, first of all, is there any induced current or not? ಅದು ನೀವು ಕೇಳಬೇಕು. ಸರ್ induced current ಬರಬೇಕು ಅಂದ್ರೆ ಏನಂತ ರೂಲ್? Again I will be recollecting with Faraday. What did he say? There should be change in the magnetic flux ಅಂತ ಹೇಳಿದ್ರು. Magnetic flux change ಆಗ್ತಾ ಇದೆ ಇಲ್ವಾ ಅಂತ ನಾನು ನೋಡ್ಬೇಕು. I am bringing the coil closer. When I bring the coil closer, what will happen? There is a relative motion with respect to the coil and as well as a magnet. ಅಂದ್ರೆ magnet ಹತ್ರ ಬಂದ್ರೂನು ಇಲ್ಲ ದೂರ ಆಗಿದ್ರೂನು The field lines cutting the coil will definitely will change. Field lines cut ಆಗಿದ ಮೇಲೆ coil change ಆಯ್ತು ಅಂದ್ರೆ sorry, field lines change ಆಯ್ತು ಅಂದ್ರೆ ಏನಂತ ಅರ್ಥ? Magnetic flux has been changed. Magnetic flux change ಆಗಿದ ಮೇಲೆ ಏನಂತ ಅರ್ಥ? There should have been a induced current. Correct? ಈಗ now what direction I should have an induced current? I don't know. When you don't know, who is you means Michael Faraday don't know. Lenz told, I'm giving a direction. What does this say? The direction of induced current has to be in opposite direction to the what exactly, or in such a way to oppose the cause. Who is the cause now? The magnet is coming closer and closer and closer. Oppose ಮಾಡಬೇಕು ಅಂದ್ರೆ ಏನಂತ ಅರ್ಥ? Then you have to repel. Who is coming closer to me now? South pole. Then to repel, then what is the pole I should get here? South pole. To get a south pole, what should have been a direction of the current that I have already learned from the moving charges and magnetism chapter? They should have been a clockwise direction of the current, so that this south pole and this south pole, both of them will repel each other. This is according to your Lenz law. That means if Lenz law is correct. Now, let me take if Lenz law fails. If Lenz law fails, what I'm doing now? South pole is coming. According to Lenz law, what did you tell? South pole only should be induced. Now I'm thinking, if the Lenz law would have not satisfied, maybe then I will take reverse. ನಿಮ್ಗಿರೋದು ಎರಡು ಆಪ್ಷನ್. ಒಂದು ಕ್ಲಾಕ್ ವೈಸ್ ಇರಬೇಕು, ಇಲ್ಲ ಆಂಟಿ ಕ್ಲಾಕ್ ವೈಸ್ ಇರಬೇಕು. ಲೆನ್ಸ್ ಲಾ ಏನ್ ಹೇಳ್ತದೆ? ದೇರ್ ಶುಡ್ ಹಾವ್ ಬಿನ್ ಎ ಕ್ಲಾಕ್ ವೈಸ್ ಅಂತ ಹೇಳ್ತಾರೆ. Now that is the reason this direction is getting. Now this fellow says what exactly? If Lenz law fails, there should have been anti-clockwise direction. So here I have anti-clockwise direction. Anti-clockwise direction andre there should have been a north pole. This is a story. Even now, what is at my logic? I need to check with this with what exactly? Law of conservation of energy. ಇಲ್ಲಿ ನೋಡಪ್ಪ, ಇಲ್ಲಿ ಏನಾಗ್ತಾ ಇದೆ? In both the cases, what is the output for me? Output is nothing but electrical energy. Then now, how can you say there is an electrical energy? Because before you move the magnet, there was no current here. Once you move the magnet, there is a current. There is a current means what does it mean? Output is nothing but electrical energy has been produced. Now the question comes, how come you get an electrical energy? Simply you will not get, right? What is the conservation of energy says? Energy can be converted from one form to the another. Total energy always remains constant. Andre there should have been somewhere, some form of energy should have been there that should have been converted into your electrical energy. Illi nodidre, let me come to if the Lenz law fails concept. Who is entering here? South pole. Who is here? North pole. Between south and north, there is an attraction or repulsion. Obviously, we know that unlike poles are attracting. So they are attracting each other. When they are attracting each other, are you doing any work? No. You just take the magnet and leave. Magnet itself will go and touch. That means I did not do any mechanical energy, or I did not do any mechanical work. I did not do any mechanical work. ಅದ್ರ ಬಿಟ್ರೆ ಏನಾದ್ರೂ ಮಾಡಕ್ ಚಾನ್ಸ್ ಇದೆಯಾ? ಯಾವ್ದು ಇಲ್ಲ. ಸೌಂಡ್ ಎನರ್ಜಿ ಬರಲ್ಲ, ಲೈಟ್ ಎನರ್ಜಿ ಬರಲ್ಲ, ಯಾವ್ದು ಬರಲ್ಲ. ಎಲೆಕ್ಟ್ರಿಕಲ್ ಎನರ್ಜಿ ಎಲ್ಲಿಂದ ಬಂತು ಅಂದ್ರೆ ಮ್ಯಾಗ್ನೆಟ್ ಮೂವ್ ಆಗ್ತಾ ಇದೆ. ಮ್ಯಾಗ್ನೆಟ್ ಮೂವ್ ಆಗ್ತದೆ ಅಂದ್ರೆ ಏನು? ಯಾರೋ ಒಬ್ರು ವರ್ಕ್ ಮಾಡಬೇಕು. ಆ ವರ್ಕ್ ಏನಯ್ಯ ಅಂದ್ರೆ ಮೆಕ್ಯಾನಿಕಲ್ ವರ್ಕ್. ಕರೆಕ್ಟಾ? ಈಗ ವೆನ್ ಯು ಹ್ಯಾವ್ ಟು ಡೂ ದ ವರ್ಕ್, ಇಫ್ ಇಟ್ ಇಸ್ ಅಟ್ರಾಕ್ಟಿಂಗ್ ಯು ಹ್ಯಾವ್ ಟು ಡೂ ವರ್ಕ್, ಆರ್ ಇಫ್ ಇಟ್ ಇಸ್ ರಿಪೆಲಿಂಗ್ ಯು ಹ್ಯಾವ್ ಟು ಡೂ ವರ್ಕ್. ಅಟ್ರಾಕ್ಷನ್ ಅಂದ್ರೆ ನೀನೇನು ಮಾಡಬೇಡ, ಅದಕ್ಕಿಂತ ಅದೇ ಹೋಗುತ್ತೆ. ರಿಪಲ್ಷನ್ ಅಂದ್ರೆ ಯಾರೋ ನಿಮ್ನು ಅಪೋಸ್ ಮಾಡ್ತಾ ಇದ್ರ, ನೌ ಯು ಹ್ಯಾವ್ ಟು ಅಪ್ಲೈ ಫೋರ್ಸ್. ಇಲ್ಲಿ ಸ್ಟಿಲ್ ದಿಸ್ ಫೆಲೋ ಇಸ್ ಅಪೋಸಿಂಗ್, ನೌ ಯು ಹ್ಯಾವ್ ಟು ಅಪ್ಲೈ. Andre, if this person is applying some 100 Newton opposition, now you have to apply more than 100 Newton, then only you can do the work. Ee particular case alli enagtade, I did not do any mechanical work. Without any mechanical work, I am getting the electrical energy. But illi nodappa, there is a south pole and as well as south pole. Now what is happening between south and south? There is an attraction or repulsion? Repulsion. When there is a repulsion, then what does that mean? You have to do the work against it. So when I have to do the work against, then between South Pole and South Pole, there will be repulsion, right? Now, there is a mechanical work. Now this mechanical work is converted into your so-called electrical energy. There is a mechanical work. That mechanical work will be converted into your so-called electrical energy. Andre ಏನಂತ ಅರ್ಥ ಈಗ? You are doing the mechanical work. That work will be converted into what? Electrical energy. That means what is the conclusion I can bring? Here the conservation of energy satisfies, even Lenz law satisfies. Here conservation of energy is not satisfied. Why conservation of energy is not satisfied? Without doing any mechanical work, you are getting electrical energy, which is completely wrong. When this is not satisfied, even your Lenz law also not satisfied. That means finally now I can give a conclusion that Lenz law is in accordance with conservation of energy. This can be important one more question even for your board exams and as well as for competitive exams. Okay, so if you observe the recent trends, competition exams ಮುಂಚೆ ಬರೀ ನ್ಯೂಮರಿಕಲ್ಸ್ ಮಾತ್ರ emphasis ಕೊಡ್ತಾ ಇದ್ರಿ, ಈಗ ಹಂಗಲ್ಲ, even conceptual questions, theoretical questions they are asking, we should be in a position to answer it. Sometimes that is going to be your time saver, okay, type of the questions, that is going to be your rank deciding questions also. Understanding? ಯಾಕಂದ್ರೆ ನ್ಯೂಮರಿಕಲ್ಸ್ ಅಂದ್ರೆ you have to actually solve, ಅಂದ್ರೆ ಟೈಮ್ ತಗೊಳುತ್ತೆ. ಕಾನ್ಸೆಪ್ಷುಯಲ್ ಕ್ವಶನ್ಸ್ ಅಂದ್ರೆ ನಿಮ್ಗೆ ಗೊತ್ತು ಅಂದ್ರೆ ಟಕ್ ಅಂತ ಮಾರ್ಕ್ ಮಾಡ್ಬೋದು, ಅಲ್ಲಿ ನಿಮ್ಗೂ ಟೈಮ್ ಸೇವ್ ಆಗತ್ತೆ. ಆ ಟೈಮ್ ಯು ಕ್ಯಾನ್ ಯೂಸ್ ಫಾರ್ ನ್ಯೂಮರಿಕಲ್ ಸಾಲ್ವಿಂಗ್. That's very important. So concentrate even on the theoretical aspects, okay, of the physics, if at all you want to be in a good position in terms of, okay, ranks for the competitive exams. So now this is a story I can bring it. So Lenz law is in accordance with conservation of energy. So because of conservation of energy only, Lenz law is derived. Now let's take up a few simple objective type of the questions related to the concept of your Lenz law. Now let me take one. There is a circular ring, okay, on its own. Imagine that down the circular line I have placed some current carrying conductor. So let me take again some three cases here. This is case number 1. Let me take, this is case number 2. This is case number 2. Let me take, this is case number 3. I hope this side of the board is visible. Yes, I can see that. Case number 3. Okay. Now, then where is the special cases? Simple. In the first case, the current is constant. In the second case, the current passing through the conductor is continuously increasing. In the third case, the current passing through the conductor is continuously decreasing. Now, in which case there is an induced current? If at all, so what should have been the direction? That is what you need to see it. If you are attending a live class, you can just take a pause for 1 minute. You can think of it. If at all you are watching a recorded video, you can take, okay, what exactly, pause and then you can try for 1 or 2 minutes. Okay. Now, Let me come for the basics of electromagnetic induction again. What did I tell? You will be getting the induced EMF only under one condition, that magnetic flux has to change. Then only you will get the induced EMF. If there is no change of magnetic flux, there is no question of induced EMF. So how to get the magnetic flux? So flux has to be equal to your so-called BA into cos theta. Now, theta stands for orientation, A stands for area, B stands for magnetic field. I'm not at all changing the coil position with respect to the wire. That means theta remains constant. So there is no change. Point number two, I'm not at all disturbing the dimensions of a coil. That means area also remains constant. Now I need to see only about what exactly B. B stands for magnetic field. So because I'm interested magnetic flux associated with a coil, that's so-called my circular coil, then I need to see who will give magnetic field this particular so-called coil. Who will give it? I can see that this coil is independently does not connect to any of the battery, then obviously it has to depend on your so-called current carrying conductor. Now, this is a straight current carrying conductor I have. This current surrounded by the current carrying conductor, there will be some magnetic flux linked with that. That flux only will be linked with this coil. Or at every point of it time, what will happen? There will be some amount of what exactly? Magnetic field will be produced. That magnetic field only will be linking with this coil in the form of magnetic flux. But you said current is constant. When current is constant, then obviously magnetic field has to be constant. Magnetic field is constant, area is constant, theta is constant. That means I can say even magnetic flux also remains constant. When magnetic flux remains constant, what did you tell me? From the concept of your Faraday's law, there should have been a change in a magnetic flux, then only you will be able to produce the induced EMF. You said there is a constant magnetic flux, so the induced EMF is equal to 0. That means the induced current also has to be 0. There is no question of producing the induced EMF here. Why? Because current is constant. Now let me come to the second case. The second case should be relatively easy for me now. Yes, case number 2. Now, current is increasing. When current is increasing, I can feel it is. Let me imagine at this point, what is the magnetic field associated with this? Is continuously increasing because magnetic field produced is directly proportional to the strength of the current. Magnetic field is continuously increasing means even flux also is continuously increasing. That's a simple logic. Now, I can write the flux is continuously increasing. Now, when flux is increasing, then I will call, sir, this is my cause. Because I have to identify during your electromagnetic induction always what the cause. Cause is nothing but change of magnetic flux. So flux is keeps on increasing. Now I have to tell about effect. What did I tell before I raised this board? So when flux is increasing, that means I have to now stop increasing the flux. I have to stop increasing the flux means two magnetic fields will be there always. One is induced field, one is existing field. Now they have to support each other or oppose each other. You only said it is increasing. Now the effect I have to what? Decrease. To decrease, then what I should do? The existing and as well as induced should be in opposite direction. So B of existing and B of induced are in opposite direction. Let me write one result in detail, then we can able to go much quickly. First now, let me take, sir, what is existing direction? Now, existing direction with whom? With a coil, that is ring. Who will give magnetic field to that? That fellow will be your conductor. Now, how do I know about this one? Right hand curl rule. Or, okay, what is that right hand curl rule says? If the thumb represents direction of current, fingers will represent direction of magnetic field. Vice versa. If fingers represent current, thumb will represent the magnetic field. Anything you want, you take it. Sir, which one to take? Simple. Depending on the shape of the conductor. Who is the shape of the conductor here? Straight line. Now, if this thumb represents current, fingers has to represent magnetic field. So, imagine if the conductor was a circular. Okay, who is the conductor means the one who is carrying the current. Then fingers would have represent current, thumb would have represent magnetic field. Vice versa, always you need to think. Now let me take. Now current is represented by the finger. Magnetic field will come like this. Now magnetic field will be taking in this direction. That means below the conductor the field is entering, above the conduction field is leaving. Inwards, outwards, inwards, outwards. Like this it will go because the fingers how you have been curled. That's a direction. So that means existing direction is which direction I have? Outwards. This is the direction of what? Outwards. Now you only said this should have been in which direction? Opposite. Now because the effect, the concept, it is coming outwards means then there should have been what exactly? Inwards. Now I have to take what exactly? Inwards. Now magnetic field is inwards. Understanding? Now curl the fingers to represent your current. Just now I told. Okay, current I and B can be interchanged from these two fingers. So existing is outwards, then induced should be what exactly? Inwards. Now let me take, so B induced should be inwards. Now to induce inwards, that means you have to represent the thumb inwards and curl the fingers. Now this should be the direction of current, which is there in your clockwise. That's a story. Let me take now third case. So simple. Sir, I is decreasing. When I is decreasing, then I can write what is the cause. So what will happen? Flux is also decreasing. Now, what should have been an effect? So what did I tell? It is decreasing means you have to oppose the decrease. Oppose the decrease means what you have to do? Increase. To increase, what you are supposed to do? Simple. To increase means you have to add. Decrease means you have to subtract. Here, what did you say? Flux is decreasing and the effect should increase. Simple. ಇಲ್ಲಿ decrease ಬಂತೆ ಅಂದ್ರೆ ಇಲ್ಲಿ increase ಬರಬೇಕು. ಇಲ್ಲಿ increase ಬರ್ತಾ ಇದೆ ಅಂದ್ರೆ ಇಲ್ಲಿ decrease ಬರಬೇಕು. Correcta? So to increase, what does it mean? The existing should be in the same direction of induced. Now let me take existing direction. Stretch the thumb, curl the fingers. Now what happened? Existing is in which direction? Outwards. So B existing is which direction? Outwards. Now B induced also should be which direction? Outwards. So I can write B induced also which direction? Outwards. Now they're also coming which direction? Outwards. That means magnetic field, induced magnetic field should be outwards. Understanding this direction, it is outwards. Now you can, okay, do like this. This is outwards. Now you can see the induced current, which is in which direction? Clockwise. So this is one story. Understood? Now we'll take up various other cases. Now, so to say that increase or decrease, you may get confused. That's the reason I have done elaboratedly. So now we can go much quickly. So imagine that there is a conductor. In this conductor, electrons are moving like this. That is from where to where? P to Q. The number of electrons is increasing with time. Then what should be the direction of the induced current? So you will get only three options in competitive exam: clockwise, anti-clockwise, and no current. And fourth option can be anything: first clockwise, then anti-clockwise, or first anti-clockwise, then clockwise, or what exactly, insufficient information, all these things. Fourth option can be anything. The three possibilities options are simple: clockwise, anti-clockwise, no current. Okay, that's the criteria. Now let me think. Now, let me remodify this question. I have to see always in terms of direction of the current. Now you said number of electrons are moving from P to Q. Now the direction of current will be always in which direction? Opposite to that. So that should be in the which direction? Now I can write Q to P. That should be in the opposite direction. Because current direction is from P to Q means, sorry, number of electrons is from P to Q, then current direction will be always from where to where? Q to P. What did you tell? Number of electrons is increasing with the time. Then what happened to the current? Current also increases with the time. Sir, you said opposite. Yeah, I said opposite only in terms of direction, not in terms of magnitude wise. After all, current is nothing but what? Rate of flow of charges. Who is the charge here? Electron. If more electrons will go, then obviously there should have been a more current. Only in terms of direction, I will take reverse. So you said current is number of electrons is increasing with the time, and even I'll say current is increasing. Now identify what is the cause. So the cause says when current is increasing, flux also increase. When flux increases, what should have been your effect? So what does it mean? The existing and as well as induced should be in opposite direction. Why, sir? I told you, always you have to oppose the change. Who is the change? Increase. Now to opposite, what does that mean? You have to decrease. That's the criteria. Now, let me come to the point. What is the direction of existing? So it will come, existing field comes due to whom? Due to the battery or due to your current carrying conductor. What is the direction of current carrying conductor? Q to P. That is from your so-called right to left. What is the direction? How do I tell? Again, take your thumb. So here conductor represent thumb and fingers represent magnetic field. Of you have to use only right hand, okay? Right hand curl rule. That's large. So this is representing the current, this representing the magnetic field. So magnetic field on the top it is going inwards, at the bottom it is coming outwards. Again in and out, in and out. Like this logic will work. Now let me take here what is the direction of the so-called induced, sorry, the so-called existing. What is the direction of existing? Here it will be inwards, here it will be outwards. So inwards means I will write the into mark. Now let me get the induced. What is the direction of the induced? I said both of them has to be in opposite direction. To have an opposite direction, they should have been what exactly? Outwards. So you stretch the thumb outwards, then you can sketch the direction of current. It will be like this. This is the direction of current. That's a simple logic. So what is the difference between the previous problem and this problem? In the previous problem, I have given in terms of what exactly? Current directly. Now slowly I just complicated the question. What is that complication I have made? Instead of giving the current, I have given with the number of electrons. That's a simple logic. Okay. Now we can take one more type of the question. So imagine from P to Q as if there is a single electron is moving. Okay, this in the previous case, number of electrons was increasing or decreasing. That's what we have studied. There are many number of electrons. This time I said there was a single electron, only one electron is moving. Now again, okay, let me modify the question. If electron is moving, of course, due to single electron also there might be minute current. So what is that? What is the direction of current? Always opposite to direction of electrons. So current is moving from where to where now? Electron is moving from P to Q. Then current has to move from where to where? Q to P. That's important. Fine, sir, you said about the direction of current. I'm happy. But what about the magnitude of current? Is it constant or increasing or decreasing? That is important because I'm looking for what? Change of the flux. Change of the flux means what? Change of magnetic field is important because B A cos theta. A is not changing, theta is not changing, only B is changing here. That's very important. So that means B will change because of I. Now I need to think what is happening. Did you get my point? Yes. Fine. Let us say T is equal to 0 to T is equal to T1. What's happening? My electron is coming towards the conductor. When electron comes towards the conductor, before electron actually enters at time T is equal to 0, current was 0 because there is no charge at all. At T1 electron has come. That means what does it mean? Some charge is there. That means obviously then I can tell here current increases. When current increases, now immediately magnetic field will increase. When immediately magnetic field increase means what does that mean? Flux also increases. Flux increases means what? B is increasing. When B is increasing, then what does that mean? Now I have to bring my effect. What is my effect? What is my effect? Simple, it has to decrease. So decrease means what does that mean? So the existing and as well as induced should be in opposite direction. Okay, because whenever you say flux cause is increasing, then effect has to decrease. That's the story. Effect has to decrease. Simple. Now let me take existing. What is the direction of existing? I need to think. What is the direction of current? You said left to right. Sorry, right to left. That is Q to P. This is the direction of current. Okay, again I'm taking my right hand. This is the direction of current. I hope you could able to feel that right left mirror image will be there in the video. I'm not sure. That's why I'm telling clearly I'm using my right hand. So Q to P. So I have used the right hand here. Now look how the direction of current, okay, magnetic field will come. Here it is entering, here it is leaving, entering, leaving, entering, leaving. That means the existing is what exactly entered. Entered means what I can write into. Now, the induced is in opposite direction means there should have been outwards. Sir, to have outwards, what should be the direction of current? This is outward. Now the direction of current comes in which direction? Anti-clockwise direction. Anti-clockwise direction. Now, let me speak about T1 to T2. Now, what is happening from T1 to T2? The electron has come from here to here. That is from T is equal to 0 to T is equal to T1. Now T1 to T2, what is happening? Electron is leaving. Electron is leaving means charge is decreasing with time. Charge is decreasing with time means current is also reducing. So I can write I decreases. Now immediately have to think, sir, when it is decreases, what is the cause? So the cause also says flux has to decrease. The flux has to decrease. Then what is the effect? Exactly opposite should come. That fellow should increase. Increase means what does that mean? Both of them existing and as well as induced should be in the same direction. So existing already which direction? Inwards. Then induced also should be which direction? Inwards. To have inwards, what does that mean? You should have clockwise. That means I can understand 0 to T1, understanding T1 to T2. So 0 to T1 I have anti-clockwise. Then T1 to T2 I have clockwise. That should be your answer. This is very important. Understanding? So many of the students, they will be good enough till the constant current. Okay. Some students will lose the marks. Okay. When I give in terms of multiple electrons, number is increasing or decreasing. And many students will lose the mark if there is a single electron. They will feel either it's in clockwise or anti-clockwise. No, you need to think like this. So first step, what you need to do, direction of current. Electrons direction will be always opposite to the direction of the current. So electrons are moving from P to Q, current has to move from Q to P. Then I understand what happened to the magnitude of current. So 0 to T1, that means current electron is approaching. So current has to increase. Correspondingly, then it has come anti-clockwise. Next, T1 to T2, electron is leaving. Electron is leaving means what does it mean? Then it will become what exactly? Current is decreasing. Then correspondingly it is coming clockwise. Sir, but it is in very minute time, right? Do you think I can able to really measure? That's not your problem. So when examiner has given, he is not worried about the reality of the situation, how much you understood this concept. That is his motto. So you need not to worry about that point. Next, so we can take up one more question. Imagine that there is a uniform magnetic field is existing as vertically inwards. I hope you might be knowing, already have studied in the moving charges and magnetism. Into says it's inwards, dot says it is outwards. So I have already taken this region of uniform magnetic field inwards. Okay. Now I'm taking it three different shapes. Okay, maybe one I will take in terms of a circle. Let me call this circle as P, Q, R, S. Okay, maybe I'm just taking the circular conductor is coming, entering to the field. Let me take one triangle, X, Y, Z. This triangle is leaving. Okay, what exactly? This particular box, I mean the region of magnetic field. And let me take one rectangle. Here I can take the rectangle as maybe let me give ABCD. Yeah, that should be fine. Capital A, B, C, D. That's the story, and it's moving like this. For this instance means what? These positions will be continuously changing. At this instance, what are the direction of induced currents in each case? If any, you need to identify. That's a simple question. Now, let me take again cause and as well as effect, the same story. Now let me take first circle first. So what is a cause? Simple. Flux is nothing but, once again, I can use like this. N into B into A into cos theta. Students, observe carefully. I'm not worried about the number of turns, and orientation is also not changing. And I said it's a uniform magnetic field. There is already fixed. Now you need to see about the area. Is it changing or not changing? You might be thinking, of course, sir, area of the circle is not changing. Students, I'm not interested in the area of the circle. I'm interested in how much is associated area of the what exactly magnetic field. So far, this much will be the area associated. What did I say? As it is entering. As it is entering means in the later stage, maybe I'll just relocate. The circle will be like this. This much will be the area associated. Sir, you said it is moving towards the right. Of course, man. Only for your information, I have written the position, but actually the position will be somewhere here. If I write the both, you may get overlap. That's the reason I have just written. Effectively, what I wanted to tell, the available area with respect to the magnetic field is increasing. When area is increasing, what will happen? Flux is increasing. When flux is increasing, then once again, what you need to do? Effect. Simple. The existing already known to you, which is nothing but vertically inwards. And now in the previous case, it was not known. That's the reason I used to take thumb and curl the fingers and everything. Blah, 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 blah. Not required. It's already inwards. Next, now I need to speak about the induced. What is the cause? Increasing. Effect has to decrease. It has to decrease means what does it mean? It should be in the opposite direction. It is an opposite direction means it should be in outwards. If it is outwards, then stretch the thumb, then curl the fingers. Outwards means it should have been what exactly? Okay, anti-clockwise direction. Anti-clockwise direction means from P to S to R to Q, then again P. So it should be PSRQP. This should have been the anti-clockwise direction. This will work as long as the area of the coil is continuously changing associated with magnetic field. Sir, once it has come completely inside, then what will happen? Once it is completely inside, then effective area associated magnetic field is maximum. That means there is no change. There is no change means what does that mean? There is no induced current at all. That is exactly the case of ABCDA. So here current will be 0. Same story for your XYZ. What's happening? Now it is coming out. When it is coming out, what does that mean? The flux value has to decrease. The flux value has to decrease means existing and as well as induced should be in same direction. Existing is which direction? Inwards. Existing is in inwards means even induced also should be inwards. Induced is inwards means this is the thumb. I'll take inwards. Now curl the fingers. Now it has to represent the direction of current. which is in which direction? Actually, I'll take now clockwise direction. Then answer will be X, Z, Y, X. That should have been the direction. So this is okay, the possible type of the questions. Yes, I think it's time up. Okay, hope you'd have understood this particular concept. Okay, from the concept of Lenz law. So I have covered the complete concepts of, I mean, to the certain extent. It is for board and as well as for the competitive exams. So these are the theoretical type of questions where no mathematical involvement, you need to put a lot of concentration to understand, but it will be very easy for you for the scoring part. So that's the reason I took this topic. And previously I concentrate was the numericals. This time I wanted to have a different change for you. That's the reason. Okay, hopefully you have followed it. Thank you so much. Sir? Hello?
ಹಲೋ ಸರ್ ಎಂಡ್ ಮಾಡಿದ್ರಿ ಸರ್? ಹಲೋ ಹಲೋ
Yes, sir. I'm audible, sir.
ಸರ್ ಎಂಡ್ ಮಾಡಿದ್ರಿ ಸರ್?
ಇಲ್ಲ, ನಾನೇನು ಏನೇನ್ ಮಾಡಿಲ್ಲ ಸರ್.
ಸರಿ ಸರಿ, ಕಂಟಿನ್ಯೂ ಸರ್, ಪ್ಲೀಸ್ ಕಂಟಿನ್ಯೂ ಸರ್.
Up 4 to 5 ಅಂತ ಹೇಳಿದ್ರಲ್ವಾ, I just completed. Is it okay, fine? Or can I continue for
You take another 5 to 10 minutes, sir, no problem.
No issue, sir. I have 2 more questions. I'll just complete it. Fine.
Okay, sir, please.
Yes, yes. Okay, students, 2 more type of the questions. What will be the possibility? Now let's discuss about it. Yeah. So imagine again, there is a uniform magnetic field like this. Okay, you have some irregular shape, some wire or something this way, irregular shape, closed loop of a wire. Imagine for this shape, you are slowly converting into a circular loop. Then what will happen? Is there any direction of the induced current? So simple. Again, I need to look at the flux. Flux is nothing but NBA into cos theta. Number of turns I'm not changing. You said magnetic field also is not changing and orientation is also not changing. Now I need to think in terms of an area. Now we need to understand what will happen. Of course, there is a change in the shape. Is the area has been changed or not? Yes, there will be change in area. For a given perimeter, circular ring always will have the maximum area. That means what's happening down the line? Area is increasing. That means if we can consider this area is A1, this area is A2. Whatever the shape other than a circle, let it be a rectangle, let it be a square, okay, let it be a triangle, let it be whatever the shape or any regular shape, for sure it will have lesser than area of the circular coil. Now area is increasing. That means flux is also getting increased. This is said to be the cause. Now this will become the effect now. So what the effect says now? It has to decrease. It has to decrease means it should be in which direction? Okay, so existing field is outwards, then induced field should have been taken in which direction? Opposite direction. So there should have been a dot. So what is that I'm supposed to do it? Originally there was no current. Now you can take it should be outwards. Outwards means it will come like this and curl the fingers. Now you can see this. This fingers will have outwards means it should be in anti-clockwise direction. That should have been a case. Okay. Now they may ask a reverse question. Sir, imagine there is a circle originally. Now if I am converting into any other shape, what will happen? Exactly opposite will come. Because for a circle, always you will have a maximum area. Now from circle to any other shape, if you are converting, then what will happen? Area will decrease, flux will decrease, then existing and as well as induced should be in what exactly? Same direction. Then the direction of current will be reverse of the what I have given. So please do think of that type of questions also. So now let's take up the last question for this session. So maybe I'll take about some non-conducting hollow cylinder like this. Okay. So this onto the top of this, I have winded a coil like your solenoid, nothing more than that. So the ends have been connected to the positive to the negative and as well as to the plug key, and I have joined like this. Okay. Now onto the top of which I have one circular plate. Imagine this circular plate it has been rested by some means. I'm not showing in a picture. Okay, it's just supporting. Now if I close this battery, what will happen to this circular ring? Okay, will it come downwards or will it go upwards or will it be there itself or as it remains as a stationary? Simple logic. Okay. Before closing the battery, just after closing the battery, now let me take. Before closing the battery, I is equal to 0. Magnetic field is 0. Then flux associated with a circular ring also will be 0. After closing the battery, the I is greater than 0 because some amount of current will shoot up. Maybe some 2, 3, 4, whatever the amperes depends on the resistance and as well as the battery strength. Now magnetic field also will increase. Then even flux also will increase. When flux will increase, then what will happen here? Again, I need to think, sir, this is a cause. So what is the cause here? Flux is increasing. Okay, so flux is increasing. Now I have to see the effect. I have to see the effect. What does it mean? The flux has to decrease because what is my rule says it always has to oppose the cause. When it is increasing, then I have to decrease. To decrease, then what I'm supposed to do? If it comes closer or should I move far away? I have only two possibilities. When it comes closer, then what does that mean? If the distance decreases between a coil and as well as the ring, then obviously the flux will increase. Now the distance has to increase. The distance has to increase means what does that mean? Then it will go upward. It will go upwards means what does that mean? Okay, the distance will increase. Distance will increase means what does that mean? The flux will decrease. That is a story. So this type of question is very important. You can see this in the even some regular state board and as well as CBSE board type of questions or the previous year questions, all these things. Maybe sometime they will change the shape like this and they will hang in terms of a pendulum, and but similar type of questions can be asked in it. Yes. Any other doubts in this? Yes. Yes, sir. Okay. Sir, can I close now?
Okay, complete, sir.
Yes, sir. Yes, sir. I have completed. Thank you, sir. Thanks for giving opportunity and thanks to all the team of the KSTA. Okay. So thank you so much.
Thank you so much. Welcome, sir.
Yes, sir.
So, dear students, please ask any questions and doubts on today's topic. Chat box ಅಲ್ಲಿ ಯಾವ questions ಕಳಿಸಿಲ್ಲ sir ಮಕ್ಕಳು.
You have to utilize this, good opportunity. Yes, and
Yes,
always
sir.
feel free. Okay, you can send even mail also, sir, if there is any
Yes, sir.
concern.
Somebody is saying YouTube.
Yes, sir.
So later on, I sent through your mail, sir.
Yes, sir. Thank you, sir. Thank you, sir.
Okay, thank you, sir. It's
Thank you,
an
sir. Thank you so much.
yes, brother.
Yes,
So thank you, Shri Sandeep, sir.
yes, sir. Thank you, sir. Thank you so much.
So this is a new informative, very informative, wonderful talk on Lenz today. So ತಮ್ಮ ಕೊಟ್ಟಿದಂತ 1 ಗಂಟೆ ಸಮಯಾವಕಾಶದಲ್ಲಿ ಹಲವಾರು ಉದಾಹರಣೆಗಳ ಮೂಲಕ ಲೆನ್ಸಸ್ ಲಾ ಬಗ್ಗೆ ಹಲವಾರು ಮಾಹಿತಿಗಳನ್ನ ವಿದ್ಯಾರ್ಥಿಗಳಿಗೆ ತಿಳಿಸ್ಕೊಟ್ಟಿದ್ದೀರಿ ಸರ್. ಸೊ
Yes, sir.
ತಮಗೆ ಈ ಒಂದು ಉಪನ್ಯಾಸ ಕಾರ್ಯಕ್ರಮವನ್ನ ತಾವು ತಮಗೆ ಕೊಟ್ಟಿದ್ದಂತ 1 ಗಂಟೆಯ ಕಾಲಾವಕಾಶದಲ್ಲಿ ಭಾರಿ ಅತ್ಯುನ್ನತವಾಗಿ ಕೊಟ್ಟಿದ್ದೀರಾ ಸರ್. ಸೊ ನನ್ನ ವೈಯಕ್ತಿಕವಾಗಿ ಹಾಗೂ ನಮ್ಮ ಅಕಾಡೆಮಿಯ ಪರವಾಗಿ ಧನ್ಯವಾದಗಳು ಸರ್.
Thank you, sir. Thank you so much.
ಸೊ ಹಾಗೂ ಈ ಒಂದು ಕಾರ್ಯಕ್ರಮಕ್ಕೆ ಹಾಜರಾಗಿದ್ದ ನಮ್ಮ ಅಕಾಡೆಮಿಯ ಅಧ್ಯಕ್ಷರಾದಂತ ಪ್ರೊಫೆಸರ್ ಅಯ್ಯಪ್ಪನ್ ಸರ್ಗೂ ಧನ್ಯವಾದಗಳು ಸರ್. ಹಾಗೂ ಈ ಒಂದು ಕಾರ್ಯಕ್ರಮವನ್ನು ಆಯೋಜನೆಗೊಳಿಸಿ ನಮಗೆ ದಿನನಿತ್ಯವೂ ಸಲಹೆ ಸೂಚನೆಗಳನ್ನು ನೀಡುತ್ತಾ ಬಂದಿರೋ ನಮ್ಮ ಮುಖ್ಯ ಕಾರ್ಯನಿರ್ವಹಣಾಧಿಕಾರಿಗಳಾದಂತಹ ಡಾಕ್ಟರ್ ರಮೇಶ್ ಸರ್ಗೂ ಧನ್ಯವಾದಗಳು ಸರ್. ಹಾಗೂ ಇಂದು ಹಾಜರಿದ್ದ ನನ್ನ ಎಲ್ಲಾ ವಿದ್ಯಾರ್ಥಿ ಮಿತ್ರರು, ಸಹೋದ್ಯೋಗಿಗಳು ಹಾಗೂ ವೆಬೆಕ್ಸ್ ವೃಂದದವರಿಗೂ ಕೂಡ ಧನ್ಯವಾದಗಳನ್ನು ಹೇಳುತ್ತಾ ಈ ಒಂದು ಉಪನ್ಯಾಸ ಕಾರ್ಯಕ್ರಮವನ್ನು ಮುಗಿಸುತ್ತಿದ್ದೇವೆ. ಸೊ ಥ್ಯಾಂಕ್ ಯು ಸರ್ ಒನ್ಸ್ ಅಗೇನ್.
Thank you, sir. Thank you so much.
ಥ್ಯಾಂಕ್ ಯು ಸೋ ಮಚ್ ಸರ್. ಸೊ ಮುಂದಿನ ಅಕಾಡೆಮಿಕ್ ಇಯರ್ ಅಲ್ಲಿ ಸರ್ ತಾವು ಕೆಲವೊಂದು ಉಪನ್ಯಾಸ ಕಾರ್ಯಕ್ರಮಗಳನ್ನ ಕೊಡ್ಬೇಕು ಅಂತ ಮತ್ತೊಮ್ಮೆ ನಾನು ತಿಳಿಸ್ತಾ ಇದ್ದೀನಿ. ಸೊ ಆ ಟೈಮಲ್ಲಿ ತಮಗೆ ಇನ್ಫಾರ್ಮ್ ಮಾಡ್ತೀನಿ ಸರ್ ನಾನು 1 ವಾರ ಮುಂಚಿತವಾಗಿ.
Yes, sir. Yes, sir. We'll plan. Thank you, sir.
Thank you, sir, once again. And also, please, ನೀವು ಕೊಟ್ಟಿರ್ತಕ್ಕಂಥ ಟಾಕ್ಗಳ ಬಗ್ಗೆ ನನಗೆ ಕೆಲವು 4 ಪೇಜ್ ನೋಟ್ಸ್ ಗಳು ಕೊಡಿ ಸರ್ ತಾವು ಕೊಟ್ಟಿರೋ ಟಾಪಿಕ್ ಮೇಲೆ.
Yes, sir. ಕಳಿಸ್ತೇನೆ ಸರ್. ನಿಮ್ಮ ಮೇಲ್ ಕಳಿಸ್ತೇನೆ ಸರ್.
ನನಗೆ ನಮ್ಮ ಅಕಾಡೆಮಿಕ್ ಮೇಲ್ ಇಲ್ಲ ಅಂತಂದ್ರೆ ನನಗೆ ಬೇಕಾದ್ರೆ ವಾಟ್ಸ್ಆಪ್ ಕಳಿಸಿದ್ರು ಕೂಡ
Fine, sir. Fine.
ನಾನು ಡೌನ್ಲೋಡ್ ಮಾಡ್ಕೊತೀನಿ ಸರ್. ಪ್ಲೀಸ್ ಸರ್, ಡೋಂಟ್ ಫರ್ಗೆಟ್ ಸರ್.
Definitely, sir. I'll send it maybe within 2 days. I'll send it, sir.
Please, sir. Please. Thank you, sir.
Thank you.